All right. So there are a couple of things I need to say before we start the class. The first thing is we um, we don't have class on Friday, as I said. We just have class every other uh, scheduled time. So the next class will be next Monday. But as you know, next Monday will be Labor Day, so that's a holiday for us. So then we have to move the class on Wednesday. All right. So the next class will be on Wednesday. Okay. So that's one thing, and then um, the what uh, the quiz. You know, I don't know if anybody has checked the website. I tried to access the website. I know some people didn't do the quiz last time, so I just talked with the Cengage people at the weekend for a long time. You know, more than 5 hours. And they agreed to extend 2 more weeks for us for the grace period. And you don't have to do anything to access website. Just follow my steps in the email and in the announcement to access website from Blackboard, and you should have no problem uh, going to accounting website, which I did. Uh, I integrated Blackboard with WebAssign. So a account was created automatically when I did that. So you should have account in WebAssign, and you should have no problem accessing WebAssign from Blackboard. So if you have not tried that yet, please try it right away after the class, because I'm planning to um, reopen the quiz on Friday. So there's no class on Friday, so you're gonna do the quiz at 1 from 1 to 1:15. So the quiz will be available right at 1 and ends at 1:15. So you have to complete the quiz and submit it before 1:15. You will not be able to see it after 1:15. Okay, so that's the second thing. And please don't leave before the class is over because I'm taking attendance. All right. Let's see any questions at this point. Let's see. So I guess those are the several things I want to say before we start the lectures. So we don't have to spend waste of time on those issues, and we can concentrate on the content of the material. I think we were talking about combined radicals last time. I think we did this page, if you remember. Um, combined like terms. So let's just continue with simplifying radicals, all right? Because it's always a hard part for students. Okay, now let's talk about the rationalizing and denominators and the numerators. What does it mean by that? It means you have some radicals either in the denominator or in the numerator, then you want to rewrite it. Like in the first example, we need to rationalize the denominator of each expression. In part A, we have 5 over 2 squared root of 3. So we got square root of 3 in the denominator. We want to rewrite the expression so that there's no radical in the denominator, but you don't want to change the problem itself. Okay, so what you do is you just multiply square root of 3 both on the top and at the bottom, just like we do fractions. So then when you multiply square root of 3 with square root of 3 at the bottom, you're going to get 3. Okay, remember? And on the top, you just have 5 over square root of 3. So at the bottom, you get 2 times 3, and you get 6. So the final answer will be 5 square root of 3 over 6. So that's pretty simple. Part B is a little more tricky because we have a cube root of 5 in the denominator. So in order to get rid of the radical in the denominator, we're going to need the cube root of 5 squared, so that when you multiply that with the cube root of 5, you're going to get the cube root of 5 cube. Okay, 5 times 5 squared, that's just 5 cube. And then you take the cube root of that, you get 5, right? But at the same time, you need to multiply the same thing on the top. So you have to multiply 2 cube root of 5 squared. So that becomes 2 times the cube root of 25. 5 squared is 25 if you do that. Okay, so that's the answer. All right, any questions on this page? No question, then we will just continue with that. Okay. Now sometimes you may have two radicals in the denominator or numerator. Okay, so then how do you rationalize the denominator or numerator in this case? Okay, we're going to use the same trick as we did in the previous two examples, but this time what you multiply is the is called the conjugate of the denominator. So in this example, we have 8 over root 6 minus root 2. So there are two radicals in the denominator. To rationalize the denominator, to make it not having any radicals in the denominator, you're going to need to multiply square root 6 plus square root 2. So change minus to plus from the previous problem. You can multiply that both on the top and at the bottom. And this is called square root 6 plus square root 2 is called the conjugate of square root 6 minus square root 2. So you just change the sign, you call them conjugate to each other. So why do we want to do that? Because when you multiply the denominator with this conjugate, if you FOIL it, so what you get is square root 6 times square root 6 plus square root 6 times square root 2 minus square root 2 times square root 6 and plus not plus minus. The last term it should be minus. I'm sorry, it's a typo here. Minus square root 2 times square root 2. Then you're gonna get the square root of 6 squared in the first term, and then the second term and the third term are the same, but with the opposite signs. Remember, you multiply square root 6 with square root 2 in different orders, you get the same thing. So they cancel each other. And in the last term is just square root 2 squared. So then square root 6 squared is just 6, and square root 2 squared is just 2. So you got 6 minus 2 in the denominator. At the same time, you need to multiply 8 with the square root 6 plus square root 2. So then we're going to get 4 in the denominator. 6 minus 2 is 4. And then you can cancel that 4 with the 8 on the top. So at the end, you get a 2 times square root plus square root 2. So that's what it do. Any questions? And you can do, you can rationalize all the numerator in the same way. So let's do a problem of rationalizing a numerator. So this time we got the problem of square root 5 minus square root 7 over 2. So on the top, there are two radicals, and we want to write it. So that after we complete the problem, there should be no radicals on the top. So again, the way to do it is to multiply the conjugate of the numerator this time, because that's you need to rationalize. So the conjugate of square root of 5 minus square root of 7 is just square root of 5 plus square root of 7. Remember, just to change the sign. And we multiply that both on top and at the bottom. Again, you can easily FOIL the top, and at the end, you can get a square root of 5 squared minus square root of 7 squared, because the cross terms will cancel each other completely. So that will give you 5 minus 7 on the top, and at the bottom you got 2 times square root of 5 plus square root of 7. 5 minus 7 is negative 2, so that you can cancel two, both on the top and at the bottom. So at the end, you get -1 over the 5 plus square 7. So there's no 2 here. Okay. No 2 in the denominator at the end. Okay, I need to correct that error also. So now we don't have any radicals on the top, but we do have radicals at the bottom. Okay. Any questions? So that's rationalizing fractions with radicals. All right. Okay. Now we talk about the forms, exponents, and we talked about the radicals, and they are interchangeable. You can change it from one form to the other. So, for example, if I write a cube root of 27, you can rewrite it as 27 to the 1/3. That's what it means for the cube root, precisely. For the square root of x cubed y to the 5 z, you can write it as x cubed y to the 5 z, the whole thing to the 1 to the half. That's the square root, right? And then the last term is we have 3x times the cube root of x squared. Okay, so you don't change the 3x in the front, but you rewrite cube root of x squared as x to the 2/3. Okay, remember in the exponent, the 2/3, the top 2 means the and the denominator 3 means the cube root. Okay, so that's how you rewrite from radicals to exponents, and that's what it means exactly by the exponents. So we got 2/3 in the exponent for x, and then we can combine with the x on the top in the first term because they are multiplying. So the first term 3x, so the exponent for x is 1 when you don't write it. So then you multiply these two, you just add on it. Okay, so you got x times 1, x to the 1 plus 2/3 times 3. And then 1 plus 2/3, if you write rewrite 1 as 3 over 3, you get that 3 plus 2 on the top, which is 5. So you get 5 over 3. So the final answer is 3 times x to the 5 over 3. Any questions? All right, no question. Let's just do one more problem. So rewriting those two forms back and forth. So this time, let's just rewrite the exponents into radicals. So in the first example, we need to rewrite x squared plus y squared to the 3/2 power. Okay, remember in the exponent of 3 over 2, 2 means the square root, 3 means the cube. So you can take the square root of x squared plus y squared and then cube it. Or you can cube x squared plus y squared first and then take the square root. You can change the order of these operations. So that's the first example. In the second example, we got 2 times y to the 3 to the 3 over 4 times z to the 1/4. Okay, so if you use the properties of exponents, you can actually factor out 1/4 from the term of y and z to get y cubed z times 1 to 1 over not times y cubed z to the 1/4 power, the whole thing, and times 2 in the front. But again, the 1 over 4 in the exponent means you take the 4th root of the whole thing. So at the end, you get the y cubed z to the 4th root and times 2 in the front. Okay. The next example, we have a to the -3/2. So you can do this problem in 2 steps. Okay. Again, we want to rewrite in radicals. So the negative exponent means you have to put this thing at the bottom. So we got 1 over a to the 3 halves. And then we can rewrite a to the 3 halves by square root of a cube. Remember the exponent 3 over 2. The 3 means you take the cube of a, and the 2 in the denominator in the exponent means you take the square root. Okay, so that's number C. And the last one, x to the 0.2. So this time we got a what, decimal. So the first step is to rewrite decimal in fractions. If you do that, you're going to get 1 over 5. So 0.2 is just 1 over 5. And then you can easily rewrite that as x to the 5th root. Okay, so that's what it means by 1 over 5 in the exponent. So so that's the changing form from exponential to radical form. Any questions for this? No question. Then let's just do it in the last page. Okay. Okay. Let's just combine all the techniques or tricks we learned so far to simplify our rational exponents. Okay. So we're not trying to rewrite this, the problem into radicals, but we're trying to simplify each problem. So in part A, we got the negative 125 to the negative 2/3. So these kind of problems are really, really confusing and very tricky. But the way to do it is you always do this step by step. Don't try to jump. It's very easy to make a mistake for these kind of problems. So if you do the first step, look at example, there's a negative. That means we need to put the whole thing in the denominator. So we can write the problem as 1 over negative 125 to the 2/3. And then remember the exponent of 2/3. That means you take the square and you take the cube root. You can do either one first. But it turns out it'll be a little easier if you take the cube root first. So why don't we just take the cube root of negative 125 and then we square it. Okay, and the cube root of negative 125 is just negative 5. Okay, if you remember, you put negative 5 by itself 3 times, you get the negative 125 basically. So we got the negative 5 to square in the denominator, which is 25. So the answer, final answer for the problem is just 1 over 25. All right. In the second example, we have 2 expressions with different variables, different exponents. We need to simplify this thing. So 4x squared y to the 3 halves times negative 3x to the negative 1/3 y to the negative 3 over 5. So to this kind of problem, you just do corresponding variable, grouping the corresponding variables together. So 4 and negative 3, there are constants. So you can multiply 4 and negative 3, you get negative 12. And for the variable x, you got the exponent 2 and the negative 1/3, which multiplying means you add the exponent. Remember? So you got a 2 plus negative 1/3, O minus 1/3. So that's 2 minus 1/3. For the y, variable y, you do the same. So you group y to the 3 halves and y to the negative 3 over 5. When you multiply them, you add the exponents. So you add 3 halves and the negative 3/5. So that become a 3 over 2 minus 3 over 5 in the exponent of y. So we are dealing with the fraction and exponents at the same time. So we got negative 12x to the 6 over 3. Can I write what you're doing? What do you mean? I think everything is written here, right? Uh, so for the part of x, 2 minus 1/3. So how do you subtract 2 and 1/3? You need to write 2 as 6, so 3/3 using the least common denominator, which is 3. Okay, so then you can subtract them. So you get 5/3 for the x exponent for x. And for y, we got 3/2 minus 3/5. So again, this the subtraction of two fractions. So you need to find the least common denominator of 2 and 5, which is 10. So then you just rewrite each fraction using the least common denominator. Mm, I think every step is writing in details. I, I don't know if there's any other step in between. So when you subtract the 5 and 3/5, you use the least common denominator 10. So you rewrite 3/2 as 15/10 if you multiply 5 both on the top and at the bottom. All right. And for 3/5, you just multiply 2 both on the top and at the bottom by 2. So you're going to get 6/10. Then you get the same denominator, 10. So you can subtract 15 and 6, you get a 9. So at the end, we got negative x to the 5/3, y to the 9/10. So that's the final answer. Number C. Okay, we got the double radical in here. Cube root of 4th root of 27. You can do this problem in different ways. For example, you can use the properties of radicals to multiply 3 and 4. You get 12. If you take the double radicals, you just multiply the two numbers in the radicals 3 and 4. You get 12 root of 127, and then you can rewrite 127 as 3 to the not 127, 27. I'm sorry, 3 cube. Okay, and then you can further rewrite the problem in the exponential form using exponents. So when you do that, you just put 12 in the denominator of the exponent and 3 on the top. So that's the property of exponents and radicals. So then you just simplify 12 by canceling 3, you get the 1/4 in the exponent. So the final answer is just 3 to the 1/4. All right. The last problem is very simple. It looks like it's complicated, but it's actually simple. So we got 3x plus 2 to the 5/2 times 3x plus 2 to the negative 1/2. All right. So remember, we got the same base. In this case, 3x plus 2. It's not a number, it's an expression, but they're the same base. So if you use the properties of exponents, just add exponents for the same base. So we just add 5/2 with negative 1/2, and you get 4/2, in the exponent. We got the same denominator too, so we don't have to change anything. And then 4/2 is just 2. So at the end, we get 3x plus 2 squared for the final answer. Any other questions for these problems? This section has a lot of basic properties for exponents and the radicals, and a lot of people got confused about these things. So please try to practice problems in the book. You can easily find the ebook in the website and do the problems in the exercise for each section. For this section, you can review the video again after class. You can also watch the video in website for this section. All right, but do practice. That will help a lot. Any other questions for this section? So we are done with this section now. So let's just start the new section 3, P3, okay? All right, and let me just share the slides with you. Okay. So we're going to do a new topic in this section. We're going to talk about polynomials and spatial products. Okay, so what is a polynomial? The definition of a polynomial is a sum of many terms, as I wrote in this on the slide. So let A0, A1, 2, A3, up to AN. So those are just the constants. Okay, they're numbers. You just note them by those symbols. So let them be real numbers, and let M be a non-negative integer. So that's also a constant, and is a non-negative integer, like 2 or 3 or 5 or 1, whatever it is. Then you get x in here. So a polynomial in x is an expression of the form of n times x to the n plus n minus 1 times x n minus 1 plus n minus 2x and minus 2, and just add all the terms down to a1x plus a0. All right, and of course the first number n is not 0. We require that. So we call this polynomial of degree n the highest power exponent n, and that's called the degree of the polynomial. And the coefficient an, the number, to multiply this term of x to the n is called the leading coefficient. And the last term is 0, the constant, without any variable with it, is the constant term. So a polynomial written with descending powers of x is in standard form. So you just arrange the terms decrease in power, and we call that form standard form. All right, that's polynomial. All right, so let's just see some examples. If you're not quite comfortable with this, variables and symbols. So let's just write the polynomials in standard form, okay? In standard form, all right? It's a table here. So in the first example, we get 4 squared minus 5x, 7 minus 2, 3x. So the standard form means we need to rearrange the terms that the power is decreasing. So you put the highest power first, which is 7. So we write the negative 5x to 7 as the first term, and the next term will be 4x squared. That's the second highest power is 2. Okay, and then 3x, and then 2. The constant is always the last one. So what's the degree? Degree is 7, the highest power of this polynomial. And leading coefficient is negative 5. The number with the x of 7 in the front. In the second problem, we got 4 minus 9x squared. Obviously, there are only terms in here. If you read in standard form, you need to put 9x squared. The negative 9x squared, the hash. So we got negative 9x squared plus 4. So the degree of this polynomial is because the hash for the x is 2. And the leading coefficient is negative 9. That's the number, say, right? 8. So that's just constant. We don't have any variable here. So the degree is 0 when you have no variable. The degree is 0. All right. And the leading coefficient is just 8 itself. It only has one. So, all right. So that's the definition of the polynomials. Okay, so let's talk about operations with the polynomials. How do you add, subtract, multiply, or divide the polynomials? So in the first example, we need to subtract the 2x squared plus 1 and x squared minus 2x plus 1. So just like you do any other things, distribute the negative sign to the second part. So you're going to get the 2x squared plus 1 minus x squared plus 2x minus 1. And then you combine like terms. 2x squared minus x squared is just x squared. And 1 minus 1 is 0. So you're just left with x squared plus 2x. All right? In the second problem, you need to multiply y squared with 4y squared plus 2y minus 3. Use the distributed y squared each term. So y squared times 4y squared, you get a 4y to the 4. Remember, you add the exponents of 2 and 2, you get 4. And then in the second term, you got the y squared times 2y. And so again, you just add 2 and 1. Remember, if you don't have any exponent on y, that means its exponent is actually 1. So you add the 2 and 1, you got 3. So the second term will be 2y cubed. And the last term is just negative 3y squared. Just multiply y squared with that number. So that's the answer. Okay, now, what if you have two polynomials like 2x minus 5 and x plus 2x minus 4 and x plus 5? You want to multiply them out. And we're going to use the FOIL method. So the FOIL method means you multiply each part, each term in the first part by each term in the second part. So that means we need to multiply 2x by x and 5, and we need to multiply negative 4 by x and 5, and then add them together. So if you multiply 2x with x, you get 2x squared. If you multiply 2x with 5, you get the 10x. 2 times 5 is 10, so plus 10x. And then you multiply negative 4 with x, you get negative 4x. And last, you get negative 4 times 5, you get negative 20. So then we got 2x squared plus 10x minus 4x minus 20. And we can combine 10x and negative 4x to get 6x. 10 minus 4 is 6. Okay. So the final answer would be 2x squared plus 6x minus 20. So that's the FOIL method. So how about 3 terms? So if you have x squared plus x minus 4 and x squared minus 2x plus 1 to multiply, you still use the same method. So you're going to multiply x squared with the second part of x squared minus 2x plus 1, and multiply x in the first part with x squared minus 2x plus 1. And also you're going to multiply negative 4 with x squared minus 2x plus 1. And then you add them together. So the method is the same. You just got more terms this time. So if you multiply x squared with x squared minus 2 plus 1, you just distribute the x squared to the second part. So x squared minus times x squared, you got the x to the 4th. X squared times negative 2x, you get the negative 2x cubed. Right? Add the exponent 2 and 1, you get 3. And the x squared times 1, you just get the x squared. And then in the second term of the first part, you get x times x squared minus 2x plus 1. So x times x squared, you get x cubed. Again, x has no exponent on it. It means the exponent is 1. So 1 plus 2 is 3. So you get x cubed. And then x times negative 2x, you get negative 2x squared. And then x times 1, you just get x. And then you get one more term, negative 4 in the first part times the second part. So negative 4 times x squared, you get negative 4x squared. Negative 4 times negative 2x, you get positive 8x. Negative 4 times negative 2 is 8. Negative 4 times 1 is negative 4. Okay, so then you just add those terms together. Because we got more terms in this example, then it'll be more convenient if you write those terms, aligned vertically for the same like terms, okay, like x cubes and x squares. So we align all the terms of x cubed vertically and align all the terms of x squared vertically. And then you can easily add subtract as there are like terms, and also x and 8x. So x to 4 has nothing to add, so you just copy down. And then you get negative 2x cubed and x cubed, so negative 2 plus 1 is negative 1, so you get negative x cubed. And then for the x squared, you get the x squared minus 2x squared minus 4x squared. So you just group them, combine them, you get the negative 5. 1 plus negative 2 plus negative 4. You get negative 5. And then x plus 8x, just 9x. 1 plus 9. And then negative 4 is nothing there. So at the end, you get the answer of x to the fourth minus x cubed minus 5x squared plus 9x minus 4. So it looks like I got a little problem with the my video to share, but you can see the slides and you can hear me anyway. Any questions for this example? So that's how you add, subtract, multiply polynomials. Okay, so now let's talk about some spatial products. Okay, so we have a few formulas here. The first formula is called the difference of sign. So if you multiply u plus v and u minus v, you're going to get the u squared minus v squared. If you FOIL them, you're going to see all the cross terms in the middle cancel each. You're just left with the square of the first term and the square of the last term and subtract. Okay, so for example, if you want to find the product of 5x plus 9 with 5x minus 9, so this is a spatial product. If you let it breaking up, what's going on? Okay, yeah. So for the formula itself, you need to check yourself at home. If you multiply u plus v and u minus v, you FOIL it. You get u squared minus u times v plus v times u minus v squared. So the minus u times v and the plus v times u cancel each other. So at the end, you can only have u squared minus v squared left if you FOIL it. So I didn't write everything here, but you can check that yourself easily, right? So if that's your question. Now let's just do one example. We need to find the product of 5x plus 9 with 5x minus 9. So if you let u equal to 5x and v equal to 9, then you can rewrite this problem as u plus v times u minus v. Okay, right? So then that's equal to u squared minus v squared. But the u is 5x and the v is 9. So you get 5x, which is 25x squared. Okay, you have to square both 5 and x. And then 9 squared is 81. So the final answer will be 25x squared minus 81. Any questions? All right. So that's the first one. And then we got the two other spatial products, the perfect squares. So u plus v squared and u minus v squared. So again, u plus v squared means u plus v times u plus v. If you FOIL it again using the method we did before, you get u squared plus u times v plus v times u plus v squared. But the u times v and v times u can be combined as 2 times u times v in the middle. So because they are multiplication, it really doesn't matter which comes first. So at the end, you get the u squared plus 2uv plus v squared. All right. Similarly, for u minus v squared, again, it's just u minus v times u minus v. So you just FOIL it. So you get u times u square, u times the negative v, you get the negative uv, and then you get the negative v times u, which is negative vu, and then negative v times negative v is positive v squared. But the middle terms or cross terms, negative uv and the negative vu, they are the same. So that gives you negative 2 uv in the middle. Again, it doesn't matter which one comes first when you multiply two numbers, right? So you can save a little time to use those formulas instead of following them every time. So let's just define the 5 minus 8x squared in this problem. So if you let u equal to 5 and v equal to 8x, then 5 minus 8x squared is just u minus v squared. So according to the formula, that will be u squared minus 2uv plus v squared. So plug in 5 for u and 8x for v, we get 5 squared minus 2 times 5 times 8x plus 8x squared. So 5 squared is just 25. 2 times 5 is 10. 10 times 8x is just 80x. So we got negative 8x in the second term. And then 8x to the square, you have to square both 8 and x. You get the 64x squared. So that's the answer, right? Okay, so let's talk about the two more here. These are the cubes, some difference of cube of more difference of two terms. In the first formula, we got u plus v squared. Okay, cube. So this time you have to multiply u plus v by itself three times. Okay, so you multiply u plus v times u plus v times u plus v, and you do u plus v times u plus v first. You get a trinomial, and then you multiply that with u plus v. So you use the formula and the Fourier method 2 times in this formula. Then at the end, when you combine all like terms, you're gonna get the formula of u cubed plus 3u squared v plus 3uv squared plus v cubed. All right. Similarly, u minus v cube, you need to multiply u minus v by itself 3 times. So u minus v times u minus v times u minus v. So you can multiply the 2u minus v first, and then you get the trinomial to multiply the last u minus v using the Fourier method. And then you combine the like terms at the end. You're going to get u cube minus 3u squared v plus 3uv squared minus v cube. I didn't write in the details of these formulas to avoid confusion. This sometimes makes confusion. You just there's formulas like this in here. Okay. So for example, if you want to find 3x plus 2 to the cube, you can use the formula in the first formula, let u equal to 3x and v equal to 2. So 3x plus 2 cube is just u plus v cube. According to the formula, that will be u cube plus 3u squared v plus 3uv squared plus v cube, if you get the first formula. And then plug in 3x to u and the v, 2 for v. So we get 3x cubed plus 3 times 3x squared times 2 plus 3 times 3x plus times 2 squared plus 2 cubed. So 3x cubed, we just multiply 3x by 3 times, or you cube 3 and cube x. So cube of 3 is 27, so you get 27x cubed in the first term. And then in the second term, we got 3 times 3x squared times 2. So if you square 3x, you get 9x squared. So you got 3 times 9x squared times 2. So 3 times 9 times 2, so that gives you 54. And then you get x squared. In the third term, 3 times 3x times 2 squared, you square first, obvious, okay, like in the second term. 2 squared is 4. So we get 3 times 3x times 4. So 3 times 3 times 4, that's just 9 times 4, so that's 36. So you got 36x. And the last term is 2 cubed, so that's just 8 if you multiply 2 by itself 3 times. All right? So one more. Okay, so this time we just use those formulas to do a problem. Um, in this problem, you can follow it term by term, but it will be a little easier if you do it by using the formulas we have in here. So in this problem, we need to find the product of x squared minus x plus 1 with x squared plus x plus 1. So let's just rewrite this problem by rearranging the terms in the two parts of the product. So I'm going to write x squared minus x plus 1 as x squared plus 1 minus x. So I put the 1 in front of x, and that doesn't change anything. Similarly, I'm going to rewrite x squared plus x plus 1 in the second term as x squared plus 1x. So now what? Now you can see you can use the formula of u minus v times u plus v, right? If you let u equal to x squared plus 1 and v equal to x. So then, the problem becomes u minus v times u plus v, and according to our first formula, that's just the u squared minus v squared, all right? So plug in x squared plus 1 as u and x as v, we got x squared plus 1 minus x squared, okay? But then we can use the perfect square formula for the first term for x squared plus 1 squared. So what you do is you just let u be x squared and v be 1, right? So x squared plus 1 squared is just u plus v squared. So according to the formula, is u squared plus 2v plus v squared. So plug in x squared for u and 1 for v, we get the x squared plus 2 times x squared times 1 plus 1 squared. X squared to the square is just x to the 4. Remember, when you take this kind of powers, it's multiply the two exponents. 2 times 2 is 4. So the first term is x to the 4th, and the second term is just 2x squared. 2 times 1 is 2. And the last term is 1 squared, just 1. So at the end, the problem is just x squared plus 2x squared plus 1 minus x squared. If you look at the third last term, the x squared plus 1 squared minus x squared, we already figured out x squared plus 1 squared is just x to the 4th plus 2x squared plus 1. And then you just minus x squared. So you just get x to the 4th plus x squared plus 1. 2x squared minus x squared, just x squared. Basically, and x 4th and 1, you don't change it. So that's the final answer. And that will be a little easier to save your time to do this kind of problems. All right. Any questions? So I'm going to post the yeah.
Could you please post
Yeah, I will post
please post this and P2? Cause you didn't post P2.
Yeah. I will do
Thank
that because I usually post the sections after 5th term. I will post the slides in the content folder of Blackboard, and hopefully the video will also be uploaded real quick today, and then you will watch it. You can watch it in Blackboard also.
All right, cool. Can you take roll? I gotta go to another class.
Okay. Yeah. I will take the room now. Okay.
It's 151.
Okay. Don't leave. Okay. Yes, I will leave also real soon today. I have a meeting myself. All right.
Man, I don't.
Somebody already left. I don't know why. So I'll see you. I already take it. Okay. So you can go now. So I'll see you on next Wednesday. All right. Next Wednesday, and I will try to reopen the quiz on Friday, as I said, from 1 to 1:15. If you missed it, you can do it. But make sure before that, make sure WebAssign is working for you. If it's not, try to contact the support in WebAssign and let them fix it. It should work now. All right. Anything else? If no question, then I will have to leave myself. I have a meeting at 2 o'clock. All right. What is it going to be? People know. Okay, that's just Um, I cannot tell you what problems will be in this quiz, but uh,
He's good.
yeah, you just look at the lecture and
All right, Mr. Lou.
slides in 2.1 and review that. Okay. Yes. Yes. Any questions? So I'm going to stop recording now.